And we're back and better than ever. We're now into chapter 11, chemical reactions. Hey, in this chapter we're going to talk about how we write out reactions or write equations. We're going to show you how to balance equations. We're going to show you how to classify the reactions. And then finally we'll be doing some predictions. Alright? Now the first thing you should realize when you're dealing with writing out equations is that you're going to be starting out with reactants on the left of the arrow, and you are going to be producing products on the right of the arrow. And that arrow can be used to say to produce. Oftentimes we use the term yields when discussing or using that arrow in a sentence. So we say reactants yield products. Reactants, plural, produces or yields products. Alright. Now the simplest way you can express a chemical reaction is by using what are called word equations. Word equations are simply that. You simply write out the compounds as their names. So you might say that you have iron plus oxygen producing or yields iron 3 oxide, which is actually rust. Alright, so there's a reaction right there. You start with iron and oxygen, you produce iron 3 oxide. Another reaction might be taking something like hydrogen peroxide. Let me scroll down here. So we have hydrogen peroxide producing water and oxygen. You're going to learn that that's a decomposition reaction. And a third one here, we'll say, methane and oxygen produces carbon dioxide and water. Or you could say water vapor. Either way. Alright, so those are some simple word equations that describe what's happening in a chemical reaction. Now, another way that you can write out equations is by using chemical equations, where instead of using the name, you actually use the formula. So let me change up the color here. Instead of saying iron plus oxygen, you might say Fe plus O2 produces Fe2O3, and that would be saying the same thing, but now you're using symbols. Alright, and that's actually a more common way of doing it. Instead of saying hydrogen peroxide, you might say H2O2 produces H2O and O2. And finally, for methane plus oxygen, the formula for methane is CH4 plus O2 produces CO2 plus H2O. Alright, so those would be some chemical equations that describe those particular reactions. Now, scrolling down here just for a second, we're talking about chemical equations right now, and there are different symbols that we use in chemical equations. We've already talked about using the plus sign to separate out the reactants or products. We also have already talked about using the arrow, meaning yields or produces. We'll be talking about this double-headed arrow more next trimester, where you're dealing with reversible reactions. But these next four, these states of matter, the solid, liquid, gas, and aqueous solution, are also very, very important. And so we should also include those in the reactions themselves. So if I scroll back up to the top, let's go ahead and insert those. Iron, in this case we're talking about as a solid, as a metal. The oxygen is a gas. And then rust is a solid. So we're going to put an S behind that. So we have an S behind the iron and an S behind the Fe2O3 to show that they're solids. And a G is placed in parentheses behind the oxygen to show that it is in fact a gas. In letter B, the hydrogen peroxide is dissolved in water. So when something is dissolved in water, we put AQ behind it for aqueous. The H2O is a liquid, so we're going to put a cursive L in there. Some people just use it as a straight line L. You can do that as well. I prefer to use it as a cursive. And the oxygen here is being evolved as a gas. So we'll put that in as well. And scrolling down just a little bit, this reaction with methane and oxygen, everything is in the gaseous phase. So we'll put a G behind the methane, behind the oxygen, behind the carbon dioxide. And in this case, we originally said that it was water vapor, so we'll put a G behind that as well because it is in the gaseous phase. Now, some reactions, as we scroll down here, require what's called a catalyst. A catalyst is going to speed up the reactions without being consumed. And so if a catalyst is involved, you usually put that catalyst over the top of the arrow. It is not a reactant because it's still there at the end of the reaction. It's not a product because it was there in the beginning. It takes part in the reaction by speeding it up, but again, it is not used up and is not produced. And one reaction in particular up here that does require a catalyst is the decomposition of hydrogen peroxide here. We use manganese dioxide as a catalyst for that particular reaction, so we're going to put MnO2 over the top of the arrow. Alright, so there's our catalyst. Now, if you have to heat something up, you can put a triangle over the arrow or just simply write the word heat. And that's also designated down here at the bottom of this table, right there. Alright, but none of the reactions above require that. Okay, so the only thing we should note, I'll just go ahead and draw an arrow, and let me change up colors. Just we'll put this, let's do this in green. That particular thing there, that's our catalyst. And again, those speed up reactions. Okay? So that's how you write out reactions. In the next podcast, we're going to start to show you how to balance equations.